Welcome to solverfy.
This is the answer to Chapter 19, problem number 71 from the Smith Organic Chemistry textbook. And this problem says, although para-hydroxybenzoic acid is less acidic than benzoic acid, ortho-hydroxybenzoic acid is slightly more acidic than benzoic acid. Explain this result. And so in order to do this, we're going to need to look at the structures of their conjugate bases. And so basically for the para-hydroxybenzoic acid, I've drawn its deprotonated, its conjugate base here. And we can draw a resonance structure where the electrons are going to move like this. So a lone pair here can add in. These electrons can kick up to here. And these electrons can revert to that carbon. And so once that happens, the conjugate, the resonance structure can look like this. So oxygen there, and then double bonds here. And so we'll have this positive charge here. I said a lone pair there with a negative charge, and then this negative charge here. And so the proximity of these two negative charges, so two negative charges close together are going to be destabilizing. So if the conjugate base is destabilized, then it's less stable, and a less stable conjugate base means a weaker acid. And so that instability, that destabilizing effect, explains why that para form is weaker. So if we look at the deprotonated version of the ortho-hydroxybenzoic acid here, what we see is that this deprotonated carboxylic acid is actually close enough to this hydrogen on the hydroxy group that it can hydrogen bond with it. And so we have some H bonding going on here. And this serves to actually stabilize. So the H bonding stabilizes the conjugate base here. Oops, it's not how you spell conjugate. So H bonding stabilizes conjugate base. And remember, a conjugate base, a stable conjugate base equals a stronger acid. So there you go. It's the ability of the ortho-hydroxybenzoic acid's conjugate base to intramolecularly hydrogen bond that stabilizes that conjugate base and therefore makes the acid a stronger acid. And that's the answer to Chapter 19, problem number 71.